Wayne Brown here, Mopar man. Mopar brake answer man. Today we're going to talk about Mopar brakes in general. Basically, we're going to talk about factory components, their combinations, and their capabilities. And in general, it's going to be an overall brake system class that basically just tells the truth. Doesn't promote any brand or model, just basically tells it like it is. That's what I'm known for. Alright friends, starting off at the beginning, this brake's on a Mopar. There's several companies and outfits that have some disc brake kits on the market that use a plate type system designed to bolt on to these drum brake spindles. For several different reasons, this is a bad idea. Number one, this drum brake spindle, you notice, is completely different from this disc brake spindle. One is big, heavy, and strong, and one is lightweight and cheesy when compared. They're subjected to different forces. Drum brake forces and disc brake forces. So, putting disc brakes on a drum brake spindles is a bad idea to begin with. Number two, those designs use a metal plate in order to hold the caliper, especially these Kelsey Hayes type calipers used on our A-bodies and our Mopars, and a company called Stainless Steel Brakes uses these. The plate system never does work right. Number one, you're using a wrong spindle, and number two, it doesn't matter on the plate, a steel plate, whether it's 1/8 inch thick or a 1/2 inch thick. When this is subjected to 2 or 3, 4, 5, 6,000 psi, the plate system is going to flex. Therefore, you'll never have great brakes because the piston's pushing on the rotor and the plate's pushing back. So, I get people that call me all the time, have bought a kit from such and such company, and they're disappointed in the brakes and the stopping power. That's because of multi-piston calipers, number one, and plate system, number two. Now, why did I say multi-piston calipers? In general, multi-piston calipers are less powerful than single piston calipers. Once again, multi-piston calipers have less clamping force than the big single piston calipers. And I'll quote Andy Finkbinder talking about piston area. When you take the sliding calipers, 2.75 inch pistons, has a total piston area of 5.940 inches. Let's just say 6 inches. You remember that. 6 square inches is important. For example, aftermarket brake system calipers using 2 1.5 inch pistons, you do the math and you come up with 3.5 square inches. Therefore, these calipers only generate 60% of the clamping force of this. These Kelsey Hayes style multi-piston calipers and others out there on the market by different companies have 50 and 60 and 70% of the clamping force of this factory caliper. That's just physics, and that's just a fact. Not promoting a brand or anything. So, and brake systems is all about hydraulic force, right? And the coefficient of friction. Different things have more resistance. So, now we've found out that we want to use a disc brake spindle. These original single piston calipers are very, very powerful. And these caliper adapters, whether they're in the sliding style or the pin style, have huge reinforcing ribs. They are extremely thick and dense and cast. Huge reinforcing ribs, extremely dense and cast. I wonder why the factory chose cast iron instead of a plate system. Would have been just as easy, if not easier. Matter of fact, I can't think of, it's on front brakes, I can't think of any automobile manufacturer on the planet that uses a plate type system. I wonder why that is. Curiosity. Let's move on to styles. Been a big debate for years. Which one's better? True sliders or the pin style, which are actually sliders too, or floaters? Well, you can use your common sense. Normally when somebody makes a part, they improve things. But because of the budget crunch, Chrysler re-engineered their braking systems. They used the pin style originally, 1969, introduced on the Imperials and C-bodies through 1972. They used the pin style. Then they changed the design, as a lot of automobile manufacturers did, and went to the sliders. Well, they're cheaper. The whole get-up's cheaper. So, I didn't say better, I said cheaper. So that leads us to believe that it may not work as well. Well, let's look at the design differences. Sliders, caliper moves back and forth on these machine ways. There are 4 of them. Holds all of the forces. This bracket takes all the forces, keeps the caliper lined up as it moves back and forth. Little bit of kink, well, you can see how a caliper might hang up every now and then. Well, have you ever heard anybody talk about sliding calipers hanging up, and maybe they do this more often than the pin style? Well, there might be something to that truth. Now, we look at these pin brackets. They have machine ways too. Here, 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 and here. Actually, these things, they've got 6 surfaces. And on top of that, they have these pins. The pins do not take any load whatsoever. They would bend or whatever. The pins help in the alignment also, all the way through the travel. So, you don't need to be a brake expert. You don't need to be an engineer. Most of this thing is common sense. Wrong spindle, right spindle. If you can, don't use sliders. Use the pin style. Okay. Now, let's talk about rotors. Rotors is a big deal. Everybody's hungry for high performance brakes, and I understand. Once again, brakes is about hydraulics and the coefficient of friction. All brakes do is they transform kinetic energy, the energy of motion, into thermal energy. And in order to do that, they have to soak up a lot of heat. I tell people all the time they don't understand what I'm talking about. A vehicle's braking system is the most powerful system on the vehicle. Why is that so? I'll tell you why. If you've got a 700 horsepower 10-second car, it takes you 700 horsepower to go down here in 10 seconds. If you stop that car in 10 seconds, which is a very long time, the brakes have absorbed 700 horsepower. If you stop that same car in 5 seconds, which is a lot more realistic, those brakes have absorbed 1,400 horsepower. If you stop that car in 2.5 seconds, These brakes and rotors have absorbed 2,800 horsepower. There you go. That's brake facts. All right. Chrysler, up through 1975, they used 11-inch rotor. It's about 1095, give or take here, there, and